All right, in this video we're going to finish lesson 3.6 and we're going to learn more about how to figure out the roots of a polynomial. And first, let's look at this warm-up. Now, this warm-up we're actually going to be referencing later on in our video, in our notes here. So make sure that you pay attention and follow along with this warm-up. But this I want you to try on your own, because I want you to list all the possible solutions to that equation using that rational root theorem that we learned about in the previous video. And then I want you to use the graph. So on your graphing calculator, I want you to graph that, and I want you to figure out of those solutions, I want you to figure out which ones you should try and which ones are in fact the real solutions to that equation. So go ahead and pause the video and hit play when you're ready to check to see if you've done that correctly. All right, let's see how you did here. So first off, when you list out, remember using that rational root theorem, we look at all the possible factors of the constant value, in this case the 2, and all the possible factors of the leading coefficient, which would be 3 for this problem. And so that's pretty simple. We just have plus or minus 1 and plus or minus 2 for what could be our numerator. In our denominator, we would have plus or minus 1 and plus or minus 3. So when you list out all those possibilities, there's only 4 numbers. Again, we got to include the plus or minus for each of those, so technically 8 possible solutions. All right, then you look at your graph. When you look at your graph, we can see that you have one that looks like it's going through -1. And you have another one that's going somewhere between 0 and 2. So when I look at those possibilities, the only ones that it could be would be 1/3 and 2/3. And so if you plug -1 into that original equation, you'd get 0 as your answer. And if you tried 2/3 first, if you tried 2/3, you'd find your other real solution. So you'd get 2 real solutions there are -1 and 2/3. Now remember that though. Okay, so we have 2 real solutions in that polynomial. Because let's look at what's called the Fundamental Theorem of Algebra. And again, there's a lot here. The key thing is to make sure you have what's written down here, what's highlighted. Is that if we have a polynomial of degree n, and the only thing that is that our degree has to be greater than or equal to 1. If that's the case, when the polynomial is set equal to 0, we're going to have exactly n solutions. Now, that second paragraph there is just kind of a side point, is that if we're dealing with factors, so any factor of multiplicity m, we're going to count the solution associated with the factor m times. So for example, if we have, like they give us there, x minus 3 to the 4th power, that means that, so that's not in standard form, so it's not a polynomial in standard form, but it's in factored form, so that polynomial has 4 solutions. Just that each of those individual solutions have the same value of 3. But when it's in standard form, in that first paragraph there, when it's in standard form, the degree would be n, and that degree tells you how many solutions you have. Now wait a minute. For this problem that we just did in our warm-up, what's the degree? The degree is 4, but we got 2 solutions. The key there is those 2 solutions that we have, those are the 2 real solutions. So you got to put everything together with what we've been talking about so far in this chapter and even in previous chapters. So remember, we could have real solutions and we could have non-real solutions. So there's supposed to be 4 solutions here. Well, we just discovered that there's only 2 of them that are real. There's only 2 x-intercepts. And at both of those x-intercepts, the line goes through the point. And so there's not a reflection point, so there's no like double roots there. So let's look at where we would get the other solutions. So what we're going to do, what we're going to do here is we're going to do this in 2 parts. Okay, so what's going on here on this screen? I don't want to overwhelm you here. So we know that 2/3, like I said, and -1 are both the real roots. So I'm going to take that 2/3. We could have started with the 2/3. We could have started with the -1. It doesn't matter. We're going to break this up into factored form. Because remember, we can use those roots to identify the factors. Because remember, that means that the 2 roots would be x minus, or the 2 factors rather, would be x minus 2/3 and x plus 1. But that's not everything. If I just multiply those together, that does not give me 3x to the 4th times plus 4x cubed and so on. There's another piece here that I'm trying to figure out. And so we're going to use the fact that those would be factors to figure out what the other factored form would be. And we can use synthetic division to do that. So here's how we would do that. So starting out with the 2/3. Again, we could have started with the 2/3 or the -1. Again, you start out with the zeros or the roots of those factors. And so if we start with the 2/3, And then we deal with all the coefficients. So the 3, the 4, the 2, the -1, and the -2. And if we use synthetic division, we would get 3, 6, 6, 3, and 0. So there's no remainder, okay, which should happen. We should not have a remainder there because it's a root. It's a 0. And so now we have, so that would mean that x minus 2/3 times what's left over, if we put that into as a polynomial, we would have 3x cubed plus 6x squared plus 6x plus 3. So if you were to multiply those two pieces together, we would get that original function. But remember, we have one other root here that we could use. We have that -1. And so what we're going to do now is we're going to use that -1 to break down that smaller piece to break it even smaller. So that the answer that we just got, the 3x cubed plus 6x squared plus 6x plus 3, we're going to break that down further. So that's what they're doing there at the bottom. So we would have -1 as our what we're dividing by into each of those pieces. So again, using synthetic division, you should know how to do that. And we're left with 3, 3, 3, and 0, which remember that we can write as an equation, which would be 3x squared plus 3x plus 3. So we would have, 3x squared plus 3x plus 3 would be that missing piece. So if I were to multiply all three of those factors together, it would give us our original function. Now, the 3x squared plus 3x plus 3, there's not going to be another root from that, another real root that we could get from that. Because remember, we saw from the graph that there's only two x-intercepts. But we have two non-real solutions. So we're going to have to take this one step further. So the only thing that I could do with that 3x cubed plus 3x plus 3 would be to factor a 3 out. So that's what's going to happen here on the next screen. So the next screen we're going to see, so we have that equation. We have the 3 that they factored out. They put that at the very beginning. So they factored that out of the 3x squared plus 3x plus 3, leaving us with x squared plus x plus 1. So now with that x squared plus x plus 1, we're going to use one of the tools in our toolbox. Okay, so we've been learning a lot of different things. Remember in the last chapter, we learned about the quadratic formula. We can use a quadratic formula to solve a quadratic equation, especially when there's going to be no real solutions. And so if you use a quadratic formula there, we end up getting -1 minus I squared root of 3 over 2 and -1 plus I squared root of 3 over 2. And I'm not going to go through the whole process. You can pause this video and you can see how the quadratic formula was used here. But the key is you would use a quadratic formula to come up with those other two non-real solutions. So now remember, using that fundamental theorem of algebra, being the degree is 4, there should be 4 solutions. 2 of them are real, the 2/3 of the -1. And we just found our other 2 solutions are non-real, the -1 minus I squared root of 3 over 2 and the -1 plus I squared root of 3 over 2. So the idea here is we're taking everything that we've learned with how to use synthetic division and how to use a quadratic formula, putting all these tools together to try to figure out what all the real and non-real solutions could be for a polynomial. So I want you guys to try this one on your own. Try to do as much as you can. Now for this problem, we know that 2 is a root of that equation. If you were to graph that out, if you use I'm not going to have you do everything here, but if we were to use that factor theorem, the rational root theorem to be able to find all the possible rational roots and then graph it, I'm just saying there's only one real root to this equation. Okay, so that real root is going to be 2. So I want you to use synthetic division to break this down to be what would this be in a factored form. And then I want you to take that solution and I want you to either use a quadratic formula or maybe another method to figure out what those other non-real solutions should be. Because think about this for a second, how many solutions should we have here? Looking at the degree of this polynomial, how many solutions should we have? Hopefully you're realizing that since the degree is 3, there should be 3 solutions. So 2 is one of those, okay, because we know that 2 is a root for that. So we know the real solution is going to be 2. So I want you to figure out what would the non-real solutions to this be. So I want you to pause the video and apply what we just did in that previous example to this one to see if you can figure out what those 2 non-real solutions would be. So hit play when you're ready to check your answer. All right, let's see how you did. So since 2 is a root, we can use synthetic division to factor that other piece down. Now when you use this synthetic division here, you would have gotten x squared plus 0x plus 5, or x squared plus 5. Now you could have used a quadratic formula if you left it as x squared plus 0x plus 5. That's totally fine. You could use a quadratic formula to get your other 2 solutions to be I squared of 5 and negative I squared of 5. Or if you looked at this as being x squared plus 5 and see that we only have one variable, you could have done what I did here in purple, which would just be to simply set it equal to 0 and solve. So I would subtract 5 from both sides, take the square root, but remember, if you take the square root, you're going to have two solutions, a plus or minus square root of negative 5. And in that situation, all we can do is realize that I can just take out an I, so I'd have I squared of plus or minus I squared of 5. So our three solutions would be 2, I squared of 5, and negative I squared of 5. Okay, so let's look at what we call conjugate root theorems. Okay, so we have conjugates. Okay, we could have the conjugate of a root, so if we have a plus square root of b, the conjugate of that would be a minus square root of b. Or we dealt with complex functions, complex numbers. So a plus bi would be a complex number, so a complex conjugate would be a minus bi. So we have a plus bi, a minus bi, or conjugate, or complex conjugates. A plus square root of b, a minus square root of b would be square root conjugates. So we're going to use that to be able to get things in factored form. Now, for those of you that are following along, maybe using a book, the book has you do this in standard form, and we've decided that is just a lot of work, and that's really not really something that's necessary that we need to do. So the idea here is we're just going to worry about getting this in factored form. Factored form is the most important. So it says here, it says, what is a quadratic function p with rational coefficients in factored form such that the function has 2 plus 5i as a root? So using what we just talked about is if 2 plus 5i was a root, that means that its conjugate is also going to be a root. That's what this paragraph is saying. So if 2 plus 5i is a root, the other one is going to be 2 minus 5i. So remember, we have that factored form is x minus p times x minus q. So if we have x minus p times x minus q, we would take, so where p and q would be your factors, or your roots, or your zeros, we would say x minus each of those. So we'd have x minus the 2 plus 5i, and x minus the 2 minus 5i. But the parentheses are really important because we're going to have to distribute that negative through. So we distribute that negative through, we're going to get x minus 2 minus 5i times x minus 2 plus 5i. And that's it. So the book would have you multiply those together. But we're just going to leave those in factored form. We're just going to stop there with that problem. So let's look at another one. Okay, so this one, so we have some things, I'm just going to put it all up here so things didn't turn out quite right. But anyhow, in this problem, we have a degree of 4 that has zeros at 3 minus the square root of 7 and 4i. So they gave us two of the zeros, 3 minus 7i, or 3 minus the square root of 7 and 4i. But it's a degree of 4, so it's supposed to be 4 zeros. So we're going to use the conjugates of the 3 minus 7i and the complex conjugate of the 4i to be able to figure out what the factored form would be. So let's start with the 3 minus the square root of 7. So 3 minus the square root of 7, the conjugate of that would be 3 plus the square root of 7. Okay, so here's the original, so here's the conjugate of that. And with the 4i, so here's the 4i that's being referenced. The conjugate of that would be, so you can look at it as 0 plus 4i, so the conjugate of that would be 0 minus 4i, or just negative 4i. So we're going to start by putting that in factored form. So it'd be x minus the 3 minus the square root of 7 times x minus the 3 plus the square root of 7 times x minus the 4i times x minus the negative 4i. And then we just distribute. We distribute the negatives through. So we'd end up getting x minus 3 plus the square root of 7 times x minus 3 minus the square root of 7 times x minus 4i times x plus 4i. And that would be it. That's where you can stop. So again, the book will have you expand that out to get it in standard form, but all we're worried about is getting it into factored form. All right, so I want you to do the same thing now. I want you to get these in factored form. So where it says standard form, don't worry about that. I want you to get these in factored form. So in the first example, they give us that one of the roots is 5 plus 4i. And so we want to get it in factored form. If we had another, what would the other root be then? And get that in factored form. And then the last problem there, we have a degree of 4. So by the way, assume with that first one that it's a degree of 2. But with the second one, we have a degree of 4, where we have 2 minus the square root of 3 and 5i as two of your roots. So you need to figure out what the other roots would be and get that one in factored form as well. So go ahead and pause the video and hit play when you're ready to check to see if you did this correctly. All right, so let's see how you did here. So in that first one, you should have got, okay, 5 plus 4i is one root, 5 minus 4i would be the other root. So all you have to do is get it in that x minus p times x minus q form, and then distribute. So we would have x minus 5 times, or x minus 5 minus 4i times x minus 5 plus 4i would be your final answer. And the other one, your roots would be 2 minus the square root of 3 and 2 plus the square root of 3. Then we'd have 5i and negative 5i. So when you put that into factored form, before distributing, you could see what you'd have there. And then after distributing, you would get x minus 2 plus square root of 3 times x minus 2 minus the square root of 3 times x minus 5i times x plus 5i. All right. So this summarizes, again, everything from this lesson, from lesson 6.6. So if you want, you can pause the video and make sure that you have all those things that are highlighted in your notes. Or, like I said, if you're creating like a cheat sheet of sorts where you have some of this key information all on one page, these would be the important things to make sure that you have on that page. So with that, I hope that you're understanding how to do this lesson a little better. And if not, make sure you come to class with your questions.